Hello.
Okay, so in problem number 1, it says that one of the legs of a right triangle has the length of 4 centimeters. And it asks us to express the length of the altitude perpendicular to the hypotenuse as a function of the length and the hypotenuse. So what we identified is that our objective is to find the function of length, no, the altitude as a function of length and the hypotenuse.
So here we found that we needed to find this line that was like that formed two different triangles.
Yeah, so basically the right triangle is right here. The base is 4, and then we don't have the hypotenuse or the altitude. So we had to establish a relationship between the area of the right triangle and the area of the other triangle that is this one.
Yeah.
It's the same triangle but with the height of A because it's perpendicular to the hypotenuse. So for that we just established the first area, the first formula for the area. It's hypotenuse times the height that the measure we want to find divided by 2, and the other one was 4 times y. That's for the right triangle.
Divided by 2.
Divided by 2. And then we're using
The Pythagorean theorem.
Pythagorean
We
theorem.
established that it is the hypotenuse squared equals to the side A that we mentioned before plus 16, which is 4 squared.
And then if we evaluate, if we solve for y, then y is the square root of the hypotenuse squared minus 16. So then A would be 4y divided by 2, 4y divided by h, as we mentioned before, because both of the areas are the same, so we equal the formulas and we then solve for A, and it's 4y divided by h. But then the y, we replace it with the square root of h squared minus 16. And the final answer was
A, which is the side that is perpendicular to the hypotenuse, it's 4 times the square root of h squared minus 16 over h. Thank you. Okay, so in problem number 15, it says that a driver sets out on a journey. For the first half of the distance, she drives at the leisurely pace of 30 miles per hour. She drives the second half at 60 miles per hour. What is the average speed on his trip?
well, first we classified information. For A, it was 30 miles per hour, and for B, it was 60 miles per hour. So x being the distance, and we established then that the time A and the time B was going to be the distance divided by
Velocity.
the velocity. So for time A, we established that it is x divided by 30, and time B, it was x divided by 60.
And then we know like that the average speed is total distance divided by total time, and we know that the total distance is 2x, and over that like it's TA plus TB, and since we already had like TA and TB, we just substituted with the x over 30 and x over 60, and then you just like simplify for x, and then like the x's cancel out and you get 40 miles per hour.
Thank you.
So in number 7, we were asked to draw the graph of the equation x plus absolute value of x equals y plus absolute value of y.
Okay, so
Considering we have two absolute values, first we had to make a calculation for what is the possible values for x. So it would be x plus x if x is greater or equal than 0. Or it would be x minus x if x was less than 0. Then the same thing for y. Y would be y plus y if y was greater or equal to 0. But it would be y minus y if y was less than 0.
So we make like all the combinations, and it is, well, I don't know if you can see, but it's like 2x plus 2y, that is the first combination. 2x equals 0, 0 equals 2y, and 0 equals 0. So this one cancels out. If we simplify, these ones are x equals y, x equals 0, and 0 equals y. So this one applies when x is greater or equal to 2 and y is greater or equal, to 0. This one applies when x is greater or equals to 0 and when y is less than 0. And this one applies when x is less than 0 and y is greater than 0. So this one is this line, x equals y or y equals x. This one is x equals 0 and this one is y equals 0 for these values. Thank you.